Everyone says Kubernetes is complex. I say it's simple. Here is why. Hello everyone, my name is Primoz aka BigPod. Let's talk about it. Okay, that statement is true but is incomplete. Yes, Kubernetes is simple, but can be as complex as you make it to be, or want it to be, or need it to be. Are there simple solutions? Yes, of course. Managed cloud. It exists. It's useful. But it isn't always available. Also, another option is running one service per server, which can be easier, but that gets real complicated real quick. As soon as you need to add additional applications. Also, just running services on a single machine or set of machines behind a reverse proxy can be easier but simpler? I don't know. Let's talk example. So let's assume cloud is out of the question. This has to be on-prem for whatever reason. We have one application that doesn't require any database. Here we go. Point a DNS to it. And we have two servers, nothing more. A DNS server and an application server. Now we have a request for additional application. This application has 4 services and uses Postgres and Redis. And if we use a most simpler version of what are our options, one server, one application, we have 8 servers. Could we combine them? Sure, but then we have to manage our reverse proxy, and that gets more complicated. But we get our next request. An application that has 3 services but cannot ever go down. Therefore, we need HA, require database, this time MySQL. Okay, so we go 7 more servers just to get app to run, but oh no, we need a load balancer. Better add 1 or 2 more servers to the mix, and here we are with 15 servers. Yes, it's a contrived example. I hear you. But let's press on. Running a single service per server is simple. If you have a single application and if you have few, it's still simple. But chance something goes wrong goes up significantly more servers you add, as well as cost goes up. Okay, now we have a load balancer. Why do we even have it? Why don't we replace load balancer with a reverse proxy that can do load balancing and combine those servers into just a handful? So we put all applications on 4 servers, split between them, or in case of HA, we put them on all servers or subset of them. We have a database server that contains all our databases, a reverse proxy server which also contains DNS. There we go, 6 servers. And just as we finished, we get another request. Now this is a big one. 3 new applications. Again, HA, many services, each database, caches, etc. You know how it goes. Now we are adding these services to servers, and they work, but server 2 is getting close to capacity. What to do? We add another server. Got few services from server 2. Now we can breathe easier, but for a bit, until server 1 goes down and we have to set everything up. So, you guessed it, we need an orchestrator to automate that. But before we involve one, let's do a recap. We have 5 app servers, 1 database server, a reverse proxy server, 7 servers in total. No real balance between them. Maybe basic automation, but still, whenever we add a new server or a new service, it's all manual. Simplistic on the face of it if you have few applications, few servers, especially if you don't have always up requirement, but in this case we do. Okay, now I did mention an orchestrator. How can an orchestrator like Kubernetes make our life easier? First, we're gonna need to decide a few things. Are databases part of our cluster? My answer generally is yes, but depending on what we're doing, it could be yes or no. It used to be that you shouldn't use a container database, but that was wrong. For our use case, it's probably okay. So we need a way to do persistent storage Since local storage is really out of the question, since we need to do things like HA, we need one server for storage, and simple NFS shares will work just fine. If later we need something better, we can migrate to something like Rook and Ceph. Another question, do we need reverse proxy capability or can we use load balanced IPs? Yes, there is option of node ports, but I was never fan of it as load balancer option is just as easy and better. If we go for ingress controller, what we need is one more configuration to set up, but we only need to do one record in DNS, while with load balanced IP option we have to edit our DNS to point to that specific IP again for easy access. Problem with ingress is that in general it is only for HTTP HTTPS things, so for anything else load balancer still works better, but it very much depends on what ingress we choose. I think for us, since we're using internal network, load balancer will work just fine, or load balanced IPs will work just fine. All we will need is block of IPs and set up metal LB into our cluster. Now you might ask, this all sounds awfully complex, especially compared to what we talked about previously. And yes, you need to make a few decisions, but that's the reason Kubernetes is so versatile, so powerful. You have choice. But once you get it up and running, it makes everything much easier. Let's talk how. Let's say we moved everything to Kubernetes. We consolidated to still 7 servers. But everything is highly available, so question isn't anymore if it should be highly available, but how many replicas does it have? Kubeproxy, part of Kubernetes, takes care of proxying and load balancing. One request gets into our cluster. Metal LB takes care of assigning IPs to services, so only thing we need to do is write a service definition and look, our ports are exposed on automatically assigned IP. If we choose ingress route, we would somehow need to assign IP to the ingress service, but that can be done manually or using Metal LB. But we would need to add additional configuration for ingress. Again, once going past ingress, Kubeproxy handles everything. Now a new request hit our desk. Again, yes, another one, but it looks pretty simple. It's a single application, 3 services, persistent storage, and already deployed database. This should be easy. But as our servers are already nearing capacity, we further decide to add a server or two to our cluster, or as they are now called, node. We grab 2 servers, load up all necessary software, aka software for our Kubernetes cluster, and add to cluster with few commands, and we start adding this new application to our cluster. After we complete adding to our cluster, we see stress on our servers is lowered. Services got balanced across servers. That was easy. No manual intervention, no choosing which server gets which service. And again, everything is highly available. Our time, our needs may change, and our Kubernetes cluster can change with those needs. Do we need more complex connectivity between containers? Add service mesh. Do we need more complex service discovery? Add other ways to do it instead of just DNS. Do we need better persistent storage? Let's add Rook. It gives us persistent storage based on Ceph and allows us to do object storage. Again, Kubernetes can support pretty simple use case, but can evolve together with how our needs evolve. Yeah, it's getting more complex, but this is where Kubernetes has its biggest trap. There is a lot of people who forget that simple Kubernetes and jump right into the end, even if they might not need that. I once called Kubernetes data center as software. And just like I wouldn't run 5 appliances in front of a single server in a data center, same you don't have to run 5 layers in front of your single application. But sometimes when we get used to those technologies, we forget simplicity some of them can have. Moral of this ramble, don't get scared away of technology. If people are saying it's complex, it just might not be. It might be as complex as you need it, or make it. But also, don't get discouraged if people say this simple variant isn't real variant. For whatever reason, they would say that. Just like Kubernetes is real Kubernetes, whether it is on 1 node or 100, where it has a service mesh, Rook, installer, or none of that, it's still Kubernetes. Thanks for watching. Don't forget to like, subscribe, comment, and I'll see you next time. Goodbye.